And now in this lecture we'll find out the value of line segment X. In the drawing we have triangle ABC. We know that side BD equals to 3 units, side DE equals to 7 units. We also know that AB is equal to AE. Angle BAD, this angle equals to theta, and also angle EAC, this angle is also equals to theta, and angle BAC, this angle, it is actually equals to 90 degrees. Angle BAC is a right angle. Angle BAC equals to 90 degrees, and we want to find out the value of side EC, or line segment EC, that is equal to X. Okay, so first of all we will define angle DAE. This angle is alpha, and from point A we draw perpendicular to BC, and we will define the touching point of the perpendicular from point A to BC as M. So actually this angle equals to 90 degrees, and this angle is also equals to 90 degrees. Okay, so in the next step we'll find out the areas of triangles BAD and triangle ADE, and we'll divide them by each other. So the area of triangle BAD here the squared brackets is the same for the area. It means the area of triangle BAD over the area of triangle DAE. So what is the area of triangle BAD? The area of triangle BAD equals to the base of the triangle, that is actually BD, times the height to the base. The height must create 90 degrees with the base BD, and you can see here that AM is indeed creates 90 degrees with the base BD, therefore the height is AM over 2. And what is the area of triangle DAE? This triangle, it equals to the base of the triangle, that is actually DE, times the height to the base. AM is the height to the base because it creates 90 degrees with the base DE, so height is AM over 2. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And what is left from this expression after we cancel 2, what is left, it is actually, we have BD times AM over DE times AM. Here AM over AM is 1, so AM will get cancelled. And it is given us in the question that BD equals to 3 units and DE equals to 7 units. So here BD is 3, DE is 7. So we found out that the area of triangle BAD over the area of triangle DAE is 3 over 7. And in the next step, we will calculate the area of triangle BAD, this triangle, in a different way. Here we took the base as AB, so the base is AB. Times the height to the base. The height must create 90 degrees with the base AB. So here, from point D, we will draw perpendicular to AB. So this angle equals to 90 degrees, and this angle is also equals to 90 degrees. And we define the touching point of the perpendicular from point D to AB as point K, and dk is the height, so we define the height dk as edge 1. So the height to the base AB is edge 1. Over 2. So the second way to calculate the area of triangle BAD is that the area of triangle BAD is equal to the base AB times the height to the base, that is edge 1 over 2. Likewise, we will do the same thing and in triangle DAE. We will calculate the area of triangle DAE in another way. Here we took the base as AE, so the base is equal to AE, and the height to the base must create 90 degrees with the base AE. So from point D we will draw perpendicular to the base AE. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees, and we will define the touching point of the perpendicular from point D to AE as O. So we have the height DO to the base AE. We will define the height DO as edge 2. So the area of triangle AED in a second way is the base AE times the height to the base AE, that is edge 2 over 2. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and what is left from this expression after we cancelled 2, what is left, it is actually AB times edge 1 over AE times edge 2. And according to what is given us in the question, AB is equal to AE. Therefore, AB over AE will be equal to 1, so AB and AE will get cancelled, and we're left only with edge 1 over edge 2. So, we will calculate the value of edge 1 and edge 2. Here, in the right triangle, triangle AKD, sinus theta will be equal to H1 over AD. H1 over AD. I repeat again, in the right triangle AKD, sinus theta will be equal to H1 over AD. We will multiply this equation by AD, and we'll get that H1 equals to AD times sinus theta. So we found out that H1 equals to AD times sinus theta. We can write here that H1 equals to AD times sinus theta. Likewise, we will find out the value of H2 here. In the right triangle ADO, we know that sinus alpha equals to H2 over AD. We will multiply this equation by AD, and we'll get that H2 equals to AD times sinus alpha. H2 equals to AD times sinus alpha. H2 equals to AD times sinus alpha. So we can substitute H2 by AD times sinus alpha. Here AD over AD is 1, so AD will get cancelled. In conclusion, we found out that according to equation number 1, three over 7 is equal to sinus theta over sinus alpha. Here we cross multiply equation number 1, and we'll get that according to equation number 1, 3 times sinus alpha equals to 7 times sinus theta. What is the value of angle alpha? First of all, we know that angle BAE equals to theta plus alpha plus theta. That is to say, angle BAE, from one side it equals to theta plus theta is 2 theta, so it is 2 theta plus alpha. So from one side angle BAE equals to 2 theta plus alpha, but from the other side we know that angle BAE, it is given us the question that angle BAE equals to 90 degrees. So from this equation 90 degrees equals to angle BAE equals to 2 theta plus alpha. We will conclude that (90 degrees) is equal to 2 theta plus alpha. This will be equation number 2. Here we will subtract 2 theta from this equation, equation number 2, and we will get that alpha equals to 90 degrees minus 2 theta. So angle alpha equals to 90 degrees minus 2 theta according to equation number 2. So here in equation number 1 states that 3 times sinus alpha equals to 7 times sinus theta. So here you can substitute alpha by 90 degrees minus 2 theta from equation number 2. We'll do it now and we'll get that according to equation number 1, 3 times sinus alpha, and alpha according to equation number 2 equals to 90 degrees minus 2 theta. That equals to 7 times sinus theta. Okay? We have the trigonometric identity that states that the value of sine 90 degrees minus x is equals to cosine x. We will use this trigonometric identity in order to find out the value of sine 90 degrees minus x. According to this trigonometric identity, the value of sine 90 degrees minus 2 theta will be equal to cosine 2 theta. So the value of sine 90 degrees minus 2 theta is equal to cosine 2 theta. So we'll substitute sine 90 degrees minus 2 theta in equation number 1 by cosine 2 theta. Okay, so we'll do it now and we'll get that 3 times sinus 90 degrees minus 2 theta equals to cosine 2 theta. So it is 3 times cosine 2 theta equals to 7 times sinus theta. And we actually have another trigonometric identity for cosine 2 theta. According to this trigonometric identity, cosine 2 theta is equal to 1 minus 2 sine square theta. So according to this trigonometric identity, we can substitute cosine 2 theta in equation number 1 by 1 minus 2 sine square theta. So we'll do it now and we will get that according to equation number 1, 3 cosine 2 theta equals to 1 minus 2 sine square theta, that equals to 7 times sinus theta. Here we will open the brackets on this side of equation number 1, and we'll get that 3 times 1 is 3, and 3 times minus 2 times 2 sine square theta is minus 6 times sine square theta, that equals to 7 times sine theta. Okay, so here we will add sine 6 sine square theta to this equation, and we will also subtract 3 from this equation, equation number 1, and we will get that according to equation number 1, 6 times sine square theta plus 7 times sine theta minus 3 equals to 0. So we have here a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to a special formula. X is actually equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay? So, in our specific quadratic equation, the variable that we are looking for is actually equals to sinus theta. So, we can write down that x equals to sinus theta. The coefficient a is equals to 6. The coefficient b equals to 7, and the coefficient c equals to minus 3. So we put the data inside the formula for x, and we'll find out the value of sinus theta, the value of the values of sinus theta. So that we will find out that x that equals to sinus theta is equal to minus b equals to 7, so minus b is minus 7, plus minus square root of b squared. B equals to 7, so b squared is 7 squared, 7 squared is 49, minus 4 times a is 6, so it is minus 4 times 6, times c, that is minus 3. All divided by 2a, and a is 6. So we found out that sinus theta is equal to minus 7 plus minus square root of minus 4 times 6 is minus 24, and minus 24 times minus 3 is 72. So in conclusion, inside the root we have 49 plus 72, all divided by 2 times 6 is 12. So we actually found out that sinus theta is equal to minus 7 plus minus 49 plus 72 is 121 over 12. So we actually found out that sinus theta is equal to minus 7 plus minus the square root of 121 is 11 over 2. So here sinus theta will have two solutions that are possible. The first solution for sinus theta is that sinus theta is equal to minus 7 minus 11 over 12. And the second solution for sinus theta is that sinus theta is equal to minus 7 plus 11 over 12. So according to the first solution for sinus theta is equal to minus 7 minus 11 is minus 18 over 12. Minus 18 over 12 is minus 1.5. So we actually found out that sinus theta is equal to minus 1.5. But because of the fact that the range of the values of sinus theta that it can sinus theta can accept values that are ranging from minus 1 to plus 1. And minus 1.5 is less than minus 1. Minus 1.5 is less than minus 1. Therefore, the solution minus 1.5 exceeds the range of sinus theta, the range of the values that sinus theta can receive. Therefore, because of the fact that it is out of the range of the values that sinus theta can receive, it is incorrect answer. That is to say, sinus theta can never receive a value of minus 1.5 because the only values that sinus theta can receive ranging between minus 1 to plus 1. Therefore, this solution is incorrect solution. We will cancel this solution and we will focus with the only solution that is possible, that sinus theta equals to minus 7 plus 11 over 12. Minus 7 plus 11 is equal to 4 over 12. Here we will divide both the numerator and the denominator of this expression by 4. 4 over 4 is 1, and 12 over 4 is 3. So in conclusion, we found out that sinus theta is equal to 1 over 3. Okay, sinus theta equals to 1 over 3. In the next step, we will prove that triangle BAM is congruent to triangle AME. Okay? Triangle BAM congruent to triangle MAE. So I will copy triangle BAM and triangle BAE in one page and new page, and we prove that they can go into each other. Actually, before that, we will focus on the isosceles triangle BAE. Triangle BAE is an isosceles triangle because of the fact that according to what is given us in the question, AB is equal to AE. Therefore, triangle BAE is an isosceles triangle. I will write it down. Triangle BAE is an isosceles triangle and BE is the base of the isosceles triangle. BE is the base and AM is the height to the base BE. Why AM is the height? Because of the fact that AM is perpendicular to the base BE, therefore AM is the height to the base. AM is the height to the base BE. Okay? So AM is the height to the base BE of the isosceles triangle, triangle ABE. And we have rule number 1. according to rule number 1, the height to the base of an isosceles triangle bisect the base. I'll repeat on rule number 1 again. According to rule number 1, the height to the base of an isosceles triangle bisect the base. So here we have the isosceles triangle, triangle ABE, and according to rule number 1, the height AM to the base BE bisect the base. That is to say, BM equals to ME according to rule number 1. Okay. BM is equal to ME according to rule number 1. So if we define BM as X, BM is equal to X according to our definition, then from this equation X equals to BM equals to ME, we will derive that ME is also equals to X. So here, so what is the value of BE? The value of side BE is equal to BM plus ME. So see it? BM equals to BE equals to BM plus ME. But BM equals to X according to our definition, and ME is also equals to X. So in conclusion, we found out that B equals to X plus X. So BE is equal to 2X from one side, but from the other side you can see that BE is equals to BD plus DE. That is to say, BE equals to BD, that is 3 units, plus DE, that is 7 units. So in conclusion, BE equals to 3 plus 7 units, that is to say, BE equals to 10 units. So in the other side, BE equals to 10 units. So from this equation, 10 equals to BE equals to 2X, we will conclude that 10 equals to 2X. We'll divide this equation by 2 and we'll get that X equals to 5 units. X equals to 5 units. So here we know that BM equals to X and ME is also equals to X. So we can write down that BM that is equal to X according to our definition is equal to 5 units, and ME that is also equals to X is also equals to 5 units. Okay? So in the next step we will focus on the right triangles, triangle ABM and triangle AME, and we will prove that those two triangles can go into each other. So I'll repeat again. We will focus on the right triangles, triangle ABM and the right triangle, triangle AMAE. And we will prove that those two triangles can go into each other. So why those two triangles can go into each other? So first of all, we know that AB is equal to AE according to what is given us in the question. AB is equal to AE, it is given us in the question. I'll repeat again, AB equals to AE, it is given us in the question. And we just right now proved that BM equals to ME equals to 5 units. BM equals to ME equals to 5 units. BM equals to ME equals to 5 units. And we have also a common side here, AM equals to itself. AM equals to AM is a common side that belongs to both triangles. So we actually proved the triangle ABM or ABM can go into triangle MAE according to side rule. Okay, I'll write it down. We actually proved the triangle ABM congruent. This is the sign of congruent to triangle MAE. According to side rule. We actually proved that all sides of triangle BAM can go into all the sides of triangle MAE, therefore we proved that those two triangles can go into each other according to side rule. And from the fact that those two triangles can go into each other, we will conclude that angle BAM is equal to angle MAE. Okay, we conclude that angle BAM is equal to angle MAE according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the two corresponding angles, that is to say BAM, this angle BAM will be equal to angle MAE, this angle MAE. Okay, so if we define angle BAM as Y, so here angle BAM equals to Y. So from this equation, Y equals to angle BAM equals to angle MAE, we conclude that angle MAE is also equals to Y. Okay? But what is the value of angle BAE? The value of angle BAE is equal to theta plus alpha. Again, the value of angle BAE equals to theta plus alpha. So from one side, the value of angle BAE equals to theta plus alpha. You can see it from the drawing. And from the other side, the value of angle BAE equals to angle BAM plus MAE. So angle BAE from one side it equals to theta plus alpha. But from the other side it equals to angle BAM plus angle MAE. So actually angle BAE from one side it equals to theta plus alpha, and from the other side it equals to angle BAM that equals to Y plus angle MAE that is also equals to Y. That is to say it equals to Y plus Y, that is to say it equals to 2Y. So we found out that angle BAE from one side it equals to theta plus alpha, and from the other side it equals to 2Y. So from this equation 2Y equals to angle BAE equals to theta plus alpha, we will conclude that 2Y equals to theta plus alpha, so here we will divide this equation by 2 and we'll get that angle Y equals to theta plus alpha over 2. So angle BAM equals to Y. So angle BAM that equals to Y will be equal to theta plus alpha over 2, and angle MAE that is also equals to Y will be also equal to theta plus alpha over 2. So we can write down that angle BAM this angle equals to theta plus alpha over 2, and angle AME or MAE, angle MAE is also equals to theta plus alpha over 2. Okay, so in the next step we'll focus on the right triangle, triangle AME. So I will copy the right triangle AME in a new page, and we'll analyze this triangle, triangle AME. So we have the right triangle, triangle AME. Here we just right now proved that angle MAE is equal to theta plus alpha over 2. We have already found out that ME equals to 5 units. So we can write here that ME equals to 5 units. And we will define side AM of the right triangle AME as H. So AM is equal to H according to our definition. So in the right triangle, triangle AME, we know that tangent theta plus alpha over 2 is equal to, this is E, okay, AME. So in the right triangle, triangle AME, this angle equals to 90 degrees. We know that tangent theta plus alpha over 2 will be equal to EM over AM. Okay, equals to EM or AM. But EM equals to 5 units. And AM equals to H according to our definition. So in conclusion, we found out that according to equation number 1, tangents theta plus alpha over 2 equals to 5 over H. Okay. In the next step, we will focus on the right triangle, triangle AMC. So I will copy the right triangle AMC in a new page, and we will analyze the right triangle, triangle AMC. First of all, what is the value of angle MAC? You can see it from the drawing that the value of angle MAC is equal to theta plus alpha over 2 plus theta. Theta plus alpha over 2 plus theta. Again, the value of this angle MAC equals to theta plus alpha over 2 plus theta. And what is the value of line segment MC? You can see it easily from the drawing that the value of MC is equal to ME plus EC. So MC equals to ME, that is 5 units, plus EC, that is X. So in conclusion, MC equals to 5 plus X. MC equals to 5 plus X. So here, MC is equal to 5 plus X. So we know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ACM, the sum of its angles is equal to 180 degrees. So angle, this angle is angle CAM, plus this angle is equal to 90 degrees, plus this angle, this is actually angle ACM. In total, the sum of those three angles must be equal to 180 degrees. So here we will subtract 90 degrees from this equation, and we will get that angle CAM plus angle ACM. In total, the sum of those two angles must be equal to 180 degrees minus 90 degrees is 90 degrees. So we subtract angle CAM from this equation, and we will get that the value of angle ACM, the angle that we are looking for, is equal to 90 degrees minus angle CAM. So angle ACM equals to 90 degrees, but we already found out that 90 degrees equals to 2 theta plus alpha, so we substitute 90 degrees by 2 theta plus alpha minus angle CAM. And we already found out that angle CAM equals to theta plus alpha over 2 plus theta. So here we will open the brackets, and we will get that the value of angle ACM is equal to 2 theta plus alpha minus theta plus alpha over 2. It is minus theta, because we have minus before brackets, so the plus sign will change to a negative sign. So we know that angle ACM is equal to 2 theta minus theta is theta plus alpha minus theta plus alpha over 2. So here theta plus alpha minus theta plus alpha over 2 will be equal to theta plus alpha over 2. Okay, so we found out that the value of angle ACM is equal to theta plus alpha over 2. So I will draw again the right triangle HCM, and we write down that angle ACM is equal to theta plus alpha over 2. So this angle ACM equals to theta plus alpha over 2. So here tangent theta plus alpha over 2 in this triangle ACM, this will be equation number 2. Tangent theta plus alpha over 2 will be equal to AM over CM. And AM equals to 5 plus X. AM equals to H. AM equals to H. And CM equals to 5 plus X. So actually, in conclusion, we found out that according to equation number 2, tangent theta plus alpha over 2 is equal to H over 5 plus X. But according to equation number 1, we have already found out that tangent theta plus alpha over 2 is equal to 5 over H. So here we'll create equation number 3. That is the combination of equation number 1 with equation number 2. So according to equation number 3, tangent theta plus alpha over 2 will be equal to, according to equation number 1, is 5 over x. And according to equation number 2, tangent theta plus alpha over 2 is equal to h over 5 plus x. Okay, so equation number 3 is a combination of equation number 1 with equation number 2. In the next step, we'll find out the value of theta plus alpha over 2. So what is the value of theta plus alpha over 2? Theta plus alpha over 2 is equal to theta plus alpha, and we have already found out that alpha equals to 90 degrees minus 2 theta, so we'll substitute alpha by 90 degrees minus 2 theta, so it is 90 degrees theta plus 90 degrees minus 2 theta over 2. That equals to, we will open the brackets, this theta plus 90 degrees minus 2 theta over 2. That equals to 90 degrees, and theta minus 2 theta is minus theta over 2. So 90 degrees over 2 is 45 degrees minus theta over 2. So in conclusion, we found out that theta plus alpha over 2 equals to 45 degrees minus theta over 2. And we know that if alpha if alpha equals to beta, then tangent alpha will be equal to tangent beta. So here tangent theta plus alpha over 2 equals to tangent 45 degrees minus theta over 2. Okay? And we actually have the trigonometric identity for tangent x minus y. Actually, tangent x minus y is equal to tangent x minus tangent y over 1 plus tangent x times tangent y. So actually we will use this trigonometric identity in order to find out the value of tangent 45 degrees minus theta over 2. According to this trigonometric identity, tangent x minus y equals to tangent x minus tangent y over 1 plus tangent x times tangent y. The value of tangent 45 degrees minus theta over 2 will be equal to tangent 45 degrees minus tangent theta over 2 divided by 1 plus tangent 45 degrees times tangent theta over 2. Okay? So tangent 45 degrees is 1. So it is 1 minus tangent theta over 2 over 1 plus tangent 45 degrees is 1 times tangent theta over 2. So in conclusion, we found out that tangent theta plus alpha over 2 equals to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. Actually, the only thing that is left to do in order to find out the value of tangent theta plus alpha over 2 is to find out the value of tangent theta over 2. We actually have a trigonometric identity for tangent theta over 2. According to this trigonometric identity, the value of tangent theta over 2 equals to sinus theta over 1 plus cosine theta. We use this trigonometric identity in order to find out the value of tangent theta over 2. We have already found out that sinus theta is equal to 1 over 3. What is the value of cosine theta? We actually have the trigonometric identity that states that sine squared theta plus cosine squared theta is equal to 1. We will subtract sine squared theta from this trigonometric identity, and we will get that cosine squared theta is equal to 1 minus sine squared theta. Here we will take a root out of this trigonometric identity, and we will get that the value of cosine theta is equal actually to the square root of 1 minus sine squared theta. But we have already found out that the value of sine theta equals to 1 over 3. So if the value of sine theta equals to 1 over 3, then the value of sine squared theta will be equal to 1 over 3 squared, that is 1 over 9. So we found out that cosine theta equals to the square root of 1 minus sine squared theta is 1 over 9, and it is the square root of 1 minus 1 over 9 is 8 over 9. 8 is 4 times 2. The square root of 4 times 2, the square root of 4 is 2, so it is 2 times square root of 2. 2 times square root of 2, and the square root of 9 is 3. So in conclusion, we found out that cosine theta is equal to 2 times square root of 2 over 3, and the value of sine theta is equal to 1 over 3. Now we can put the value of sine theta and cosine theta in this equation in order to find out the value of tangent theta plus alpha over 2. And we get that the value of tangent theta plus alpha over 2 is equal to 1 minus tangent theta over 2, and the value of tangent theta here actually we will find out the value of tangent theta over 2. First of all, we will find out the value of tangent theta over 2. So we use this trigonometric identity that tangent theta over 2 equals to sinus theta, and sinus theta is 1 over 3 over 1 plus cosine theta, and cosine theta is 2 times square root of 2 over 3. So it is 1 over 3 over, we'll multiply 1 by 3 and then we'll divide it by 3 in order to have a common factor with this expression. So it will be 3 plus 2 times square root of 2 divided by 3. Here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. And we found out that tangent theta over 2 equals to 1 over 3 plus 2 times square root of 2. So I write it in here that we found out that the value of tangent theta over 2 is equal to 1 over 3 plus 2 times square root of 2. So here we will simplify this expression. Actually, the expression y 1 over 3 plus 2 times square root of 2, we can multiply it by 3 minus 2 times square root of 2, and then we will divide it by 3 minus 2 times square root of 2, and we will get that here in the numerator we have 3 minus 2 times square root of 2, and in the denominator we have expression that is very similar to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. Here a equals to 3, so a squared is 3 squared, 3 squared is 9, minus b squared. B equals to 2 times square root of 2, so b squared is 2 times square root of 2 squared, that is actually 8, so it is minus b squared is minus 8. So we found out that this expression equals to 3 minus 2 times square root of 2. So we can write down that tangent theta over 2 equals to 3 minus 2 times square root of 2. Now we can put the value of tangent theta over 2 inside the equation for tangent theta plus alpha over 2. We have the equation that states that tangent theta plus alpha over 2 is equal to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. Okay, so and we already found out that tangent theta over 2 equals to 3 minus 2 times square root of 2. So we put the value of tangent theta over 2 inside this equation, or we'll substitute tangent theta over 2 by 3 minus 2 times square root of 2, and we'll get the tangent theta plus alpha over 2 is equal to 1 minus tangent theta over 2 is 3 minus 2 times square root of 2 over 1 plus tangent theta over 2 is 3 minus 2 times square root of 2. Okay, so we actually found out that tangent theta plus alpha over 2 equals to 1 minus 3 is minus 2, minus and minus is plus, so it is plus 2 times square root of 2 over 1 plus 3 is 4, minus 2 times square root of 2. So here tangent theta plus alpha over 2 is equal to 2 times square root of 2 minus 2 over 1 plus 3 is 4 minus 2 times square root of 2 so here we will take out 2 as a common factor from the numerator and we will get that it's 2 times square root of 2 minus 1 over here from the denominator we will take 2 times square root of 2 is a common factor, so inside the brackets we will have square root of 2 because 2 square root of 2 times square root of 2 is 4 minus 1. So here 2 square root of 2 minus 1 over square root of 2 minus 1 is 1, so it will get cancelled. And we have 2 over 2, it also will get cancelled. So in conclusion, we found out that tangent theta plus alpha over 2 equals to 1 over square root of 2. I write it again that the value of tangent theta plus alpha over 2 equals to 1 over square root of 2. Okay, and we have equation number 3. According to equation number 3, we have already found out that according to equation number 3, we have already found out that tangent theta plus alpha over 2 equals to 5 over h, that equals to h over 5 plus x, and we just right now found out that tangent theta plus alpha over 2 is also equals to 1 over square root of 2. So here we create the first equation. From equation number 3 we will derive that 5 over h equals to 1 over square root of 2. Here we cross multiply this equation and we will get that h equals to 5 times square root of 2. And we will also create this equation that states that h over 5 plus x equals to 1 over square root of 2. Again, h over 5 plus x equals to 1 over square root of 2. And we already found out that h equals to 5 times square root of 2. So we substitute h in this equation by 5 times square root of 2. We'll do it now and we get that 5 times square root of 2 over 5 plus x equals to 1 over square root of 2. Here we cross multiply this equation and we get that 5 times square root of 2 times square root of 2 equals to 5 plus x. And square root of 2 times square root of 2 is 2 and 2 times 5 is 10. So in conclusion, we found out that 10 equals to 5 plus x. We subtract 5 from this equation and we get that x equals to 10 minus 5 is 5. So we found out that x equals to 5 units. X that is also equals to CE equals to 5 units according to what we have found out just right now. So the answer to the question that x that equals to CE equals to 5 units. This line segment CE that equals to x is equal to 5 units. In the next step I will summarize the lecture. So here we have triangle ABC. We know that AB is equal to AE. We also know that BD equals to 3 units, DE equals to 7 units. Angle BAD equals to theta, angle EAC is also equals to theta, and angle BAC equals to 90 degrees. And we want to find out the value of line segment EC that equals to x. Okay, so first of all, we calculated the ratio between the area of triangle BAD over the area of triangle DAE. The area of triangle ABD is equal to the base of the triangle that is BD times the height to the base that is AM over 2. I'll repeat again, the area of triangle BAD equals to the base BD times the height to the base that is AM. Here, the height AM creates 90 degrees with the base BD, therefore AM is indeed the height to the base of the base BD. So the area of triangle BAD equals to the base BD times the height AM over 2. And what is the area of triangle AED? The area of triangle MAE, the area of triangle AED, this triangle AED will be equal to the base of the triangle that is DE times the height to the base AM. You can see that AM creates 90 degrees with the base DE, therefore AM is indeed the height to the base. So, in conclusion, we found out that the area of triangle AED equals to the base of the triangle that is DE times the height to the base that is AM over 2. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And we're left with BD times AM over DE times AM. AM over AM is 1, so it will get cancelled. And we're left with BD over DE. BD equals to 3. And D equals to 7. So in conclusion, we found out that the area of triangle BAD over the area of triangle DAE equals to 3 over 7. Then we calculated the area of this triangle ABD in a different way. We can say that the area of this triangle ABD equals to the base AB. Now the base is AB times the height to the base that is DK over 2. The height DK creates 90 degrees with the base AD, therefore the height is indeed DK that we defined as H1. So in conclusion, the area of triangle ABD equals to the base AB times the height H1 over 2. Likewise, we calculated the area of triangle AED in a different way. We took AE as the base times the height to the base. The height must create 90 degrees with the base AE, and indeed AO creates 90 degrees with the base AE, and we defined DO as H2. DO equals to H2 according to our definition. So in conclusion, we found out that the area of triangle AED equals to the base AE times the height H2 over 2. We'll repeat again, the area of triangle AED equals to the base AE times the height H2 over 2. 2, we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and we left only with AB times H1 over AE over AE times H2. AB equals to AE, so AB over AE it will be equal to 1, so it will get cancelled, and we left only with H1 over H2. So we'll find out the values of H1 and H2, and we substitute H1 and H2 by the values that we found out from them. So we focused on the right triangle AKD. In this right triangle, we can say that sinus theta equals to H1 over AD. In the right triangle ADK, sinus theta equals to H1 over AD. We multiply this equation by AD, and we got that H1 equals to AD times sinus theta. Likewise, so we can substitute H1 by AD sinus theta. Then we found out the value of H2 in the right triangle AOD. this right triangle, we can find out that sinus alpha equals to H2 over AD. Yeah. Sinus alpha equals to H2 over AD. We multiply this equation by AD, and we found out that H2 equals to AD times sinus alpha. So we can substitute H2 by AD sinus alpha. We did it, and in conclusion, we found out that 3 over 7 equals to sinus. But before that, we have AD in the numerator and AD in the denominator, so AD will get cancelled. And in conclusion, we found out that 3 over 7 equals to sinus theta over sinus alpha. We cross multiply the equation number 1, and we got that 3 times sinus alpha equals to 7 times sinus theta. Then we know from the drawing, we know that angle BAE equals to 90 degrees from one side, but from the other side, angle BAE equals to theta plus alpha plus theta, that is to say it equals to 2 theta plus alpha. From one side, angle BAE equals to 90 degrees, and from the other side, angle BAE equals to 2 theta plus alpha. Here, from this equation, we will derive that 90 degrees equals to 2 theta plus alpha. We subtract 2 theta from this equation, equation number 2, and we find out that angle alpha equals to 90 degrees minus 2 theta. So therefore, we can substitute angle alpha by 90 degrees minus 2 theta in equation number 1. We did it, and we got that 3 times, and instead of alpha, we wrote down 90 degrees minus 2 theta, that is equal to alpha, that equals to 7 times sinus theta. And we have the trigonometric identity that states that sinus 90 degrees minus x equals to cosine x. According to this trigonometric identity, we get that the value of sinus 90 degrees minus 2 theta equals to cosine 2 theta. So we can substitute sinus 90 degrees minus 2 theta in equation number 1 by cosine 2 theta. We did it, and we got that 3 times, and instead of sinus 90 degrees minus 2 theta, we wrote down cosine 2 theta. So we got that 3 times cosine 2 theta equals to 7 times sine theta. Here we have the trigonometric identity that states that cosine 2 theta equals to 1 minus 2 sine squared theta. So we can substitute cosine 2 theta in equation number 1 by 1 minus 2 sine squared theta. We did it, and we got that 3 times, instead of cosine 2 theta, we wrote down 1 minus 2 sine squared theta, that equals to 7 times sine theta. Here we open the brackets on this side of equation number 1. 3 times 1 is 3, and 3 times minus sine squared theta is equals to minus 6 times sinus squared theta, that equals to sinus 7 sinus theta. Here we added 6 sinus squared theta, and we also subtracted 3 from this equation, and we got the quadratic equation that states that 6 times sinus squared theta plus 7 times sinus theta minus 3 equals to 0. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. When a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following equation, the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2. In the other specific equation we know that x equals to sinus theta. It is the variable that we are looking for. A equals to 6, b equals to 7, and c equals to minus 3. So we put the data inside this formula for x in order to find out the value of sinus theta. And we found out that sinus theta equals to minus b. B equals to 7, so minus b is minus 7 plus minus square root of b squared minus 4 times ac. B is 7, so b squared is 7 squared, that is 49, minus 4 times a is 6, times c is minus 3. So here 4 times minus 4 times 6 is minus 24, and minus 24 times minus 3 is 72. So in conclusion, we found out that sinus theta equals to minus 7 plus minus square root of 49 plus 17, 49 plus 72 over 12, and 49 plus 72 is 121. So in conclusion, we found out that sinus theta equals to minus 7 plus minus square root of 121 over 12. And the square root of 121 is 11. So in conclusion, we found out that sinus theta equals to minus 7 plus minus 11 over 12. So here we have two solutions that are possible for sinus theta. The first solution is sinus theta equals to minus 7 minus 11 over 12, and the second solution is that sinus theta equals to minus 7 plus 11 over 12. And so in the first solution, sinus theta equals to minus 7 minus 11, that is minus 18. So here we found out that sinus theta equals to minus 18 over 12, that is minus 1.5. But because of the fact that that sinus theta can receive values, can accept values that their range is only from minus 1 to plus 1, and minus 1.5 is less than minus 1, it means that the answer minus 1.5 is not in the range of the values that it can receive. That is to say, sinus theta can never be equal to minus 1.5. Therefore, this answer is not correct answer. We'll cancel this answer. We'll focus on the second answer, that sinus theta equals to minus 7 plus 11 over 12. Minus 7 plus 11 is 4. So sinus theta equals to 4 over 12. Here we divided both the numerator and the denominator on this side of the equation by 4. 4 over 4 is 1, and 12 over 4 is 3. So in conclusion, we found out that sinus theta equals to 1 over 3. Then we have here, we know that triangle ABE is an equilateral triangle because of the fact that AB equals to AE. Okay, triangle ABE is an equilateral triangle. The base of the triangle is BE, and the height is AM. Why? Because the height AM is perpendicular to the base, therefore the height is AM. And then I presented to you rule number 1. According to rule number 1, the height to the base in an the height to the base in an isosceles triangle bisects the base. So here we have the height AM to the base BE in the isosceles triangle ABE. So according to rule number 1, the height AM bisects the base BE. That is to say, according to rule number 1, BM equals to ME. Okay, I'll repeat again. According to rule number 1, BM equals to ME. So if we define BM as X, then from this equation X equals to BM equals to ME, we will conclude that ME is also equals to X. So BM equals to X and ME is also equals to X, but that is from one side. But what is the value of BE? BE is equal, the value of BE is BE equals to BM plus ME. Okay? BE from the other side, B equals to BM plus ME, but BM equals to X and ME is also equals to X. So BE from the other side equals to X plus X. Okay, that is 2X. So from the other side, B equals to 2X, and from one side it equals, from one side it equals the value of BE. You can see it from the drawing that BE equals to BD plus DE. That is to say, BE equals to BD, that is 3 units, plus DE, that is 7 units. So in conclusion, I found out that B equals to 3 plus 7 units, it is 10 units. So from the other side, from one side, B equals to 10 units. From the other side, B equals to 2X. So from this equation, 10 equals to B equals to 2X, we derive that 10 equals to 2X. We divide this equation by 2 and we get that X equals to 5 units. So X, that is BM, is equal to 5 units, and ME, that is also equals to X, is also equals to 5 units. So we can write down here that BM, that equals to X, equals to 5 units, and ME, that is also equals to X, is also equals to 5 units. Okay? Then we prove the triangle ABM and triangle MAE can go into each other. So why triangle ABM can go into triangle MAE? First of all, AB equals to AE. It is given us in the question. AB equals to AE. We also know that we just right now found out that BM equals to ME equals to 5 units. BM equals to ME. And AM equals to itself. AM equals to AM. It's a common side that belongs to both triangles. So we actually found out that triangle ABM can go into triangle MAE according to side rule. From the fact that those two triangles can go into each other, we will conclude that angle BAM equals to angle MAE. Angle BAM, this angle, is equal to angle MAE, is equal to this angle. Okay? According to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding angles will be also equal to each other. That is to say, angle BAM equals to angle MAE. And if we define angle BAM as y, then from this equation y equals to angle BAM equals to angle MAE, we will conclude that angle MAE is also equals to y. So angle BAM equals to y and angle MAE is also equals to y. And what is the value of angle BAE? The value of this angle BAE is actually equals to theta plus alpha. From one side, angle BAE equals to theta plus alpha. Okay? But from the other side, angle BAE equals to angle MAE plus angle BAM. Angle BAE equals to angle BAM plus angle MAE. Okay? But angle BAM is equal to y and angle MAE equals to y. So from one side, angle BAE equals to y plus y, that is 2y, and from the other side, angle BAE equals to theta plus alpha. So from this equation, 2y equals to angle BAE equals to theta plus alpha, we will conclude that 2y equals to theta plus alpha. We divided this equation by 2 and found out that angle y equals to theta plus alpha over 2. So angle BAM, this angle that equals to y will be equal to theta plus alpha will be equal to theta plus alpha over 2, and angle MAE that is also equals to y will be also equal to theta plus alpha over 2. Okay, I will repeat again. Angle BAM will be equal to theta plus alpha over 2, and angle MAE will be also equal to theta plus alpha over 2. Okay, then I copied the right triangle MAE in this new page. We already found out that angle EAM equals to theta plus alpha over 2. We defined AM as edge, and we already found out that ME equals to 5. So here in the right triangle AME, we can write down that triangle theta plus alpha over 2 will be equal to EM over AM. EM over AM, but EM equals to 5 units and AM equals to edge according to our definition. So in conclusion, we found out that triangle theta plus alpha over 2 equals to 5 over edge. This is equation number 1. Then we created equation number 2. We copied the right triangle MAC in the new page, and we analyzed triangle MAC. This is triangle AMC, and what is the value of angle what is the value of angle CAM? The value of angle CAM will be equal to theta plus alpha over 2 plus theta. Okay, it is equal to theta plus alpha over 2 plus theta. And what is the value of CM? CM equals to, or MC equals to ME plus EC. So it is ME that is 5 plus EC that is X. So in conclusion, we found out that CM equals to 5 plus X. Okay? And we know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ACM, the sum of its angles must be equal to 180 degrees. So angle CAM, this angle, plus 90 degrees, plus this angle, this is actually angle MCA or ACM. In total, the sum of those three angles must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we got that angle CAM plus angle ACM equals to 90 degrees minus 180 degrees minus 90 degrees is 90 degrees. We subtracted angle CAM from this equation, and we got that angle ACM, the angle that we are looking for, equals to 90 degrees minus angle CAM. And we have already found out that angle CAM equals to theta plus alpha over 2 plus theta. Okay? So, in conclusion, we found out that angle ACM equals to 2 theta, and here, in conclusion, found out that angle ACM equals to 90 degrees minus theta plus alpha over 2 plus theta. Okay? Here, we substitute the angle CAM by theta plus alpha over 2 plus theta. And we have already found out that 90 degrees is equal to 2 theta plus alpha. So we substituted 90 degrees by 2 theta plus alpha. So in conclusion, we found out that angle ACM equals to 2 theta plus alpha minus theta plus alpha over 2 plus theta. We open the brackets here, and we got that angle ACM equals to 2 theta plus alpha minus theta plus alpha over 2 minus theta. Because we have minus before the brackets, the plus sign will become minus. So here we have 2 theta minus theta is theta. So in conclusion, we found out that angle ACM equals to theta plus alpha minus theta plus alpha over 2. Theta plus alpha minus theta plus alpha over 2 is theta plus alpha over 2. So we found out that angle ACM, the angle that we are looking for, equals to theta plus alpha over 2. So here, this angle ACM equals to theta plus alpha over 2. So here, in this right triangle ACM, we can write down that angle theta plus alpha over 2 equals to AM over CM. AM equals to 5 plus X. CM, tan theta plus alpha over 2 equals to AM over CM. AM equals to H. CM equals to 5 plus X. So in conclusion, we found out that according to equation number 2, tan theta plus alpha over 2 equals to H over 5 over H. Tan theta plus alpha over 2 equals to H over 5 plus X. And according to equation number 1, tan theta plus alpha over 2 equals to 5 over H. Then we created the equation number 3 that states that is the combination of equation number 1 with equation number 2. According to equation number 3, tan theta plus alpha over 2 equals to 5 over H according to equation number 1, and it is also equals to H over 5 plus X according to equation number 2. Then we found out the value of theta plus alpha over 2. The value of theta plus alpha over 2 is equal, theta plus alpha over 2 equals to theta, and we have already found out that alpha equals to 90 degrees minus 2 theta. So we substitute alpha by 90 degrees minus 2 theta divided by 2. We open the brackets here and we got that theta plus 90 degrees minus 2 theta over 2. Theta, and we have 90 degrees, and theta minus 2 theta is minus theta. So in conclusion, we found out that theta plus alpha over 2 equals to 90 degrees minus theta over 2. 90 degrees over 2 is 45 degrees, and here we have 2 minus theta over 2. So in conclusion, we found out that theta plus alpha over 2 equals to 45 degrees minus theta over 2. And if alpha equals to beta, then tangent alpha will be equal to tangent beta. Therefore, tangent theta plus alpha over 2 will be equal to tangent 45 degrees minus theta over 2. And according to the trigonometric identity, the tangent x minus y equals to tangent x minus tangent y over 1 plus tangent x times tangent y, you will get that the value of tangent 45 degrees minus theta over 2 will be equal to tangent 45 degrees minus theta over 2 over 1 plus tangent 45 degrees times tangent theta over 2. And tangent 45 degrees is 1, so we get here 1 minus tangent theta over 2 over 1 plus tangent 45 degrees is 1. So here what is left is tangent theta over 2. So in conclusion, we found out that tangent theta plus alpha over 2 equals to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So the only thing that is left to do in order to find out the value of tangent theta plus alpha over 2 is to find out the value of tangent theta over 2. And we have the trigonometric identity that states that tangent theta over 2 equals to sinus theta over 1 plus cosine theta. We have already found out that sinus theta equals to 1 over 3. And according to the trigonometric identity, that sinus square theta plus cosine square theta equals to 1. If we subtract from this trigonometric identity sinus square theta, we will get that cosine square theta equals to 1 minus sine square theta. If we take root from this equation, we get that cosine theta equals to the square root of 1 minus sine square theta. So if sine theta equals to 1 over 3, then sine square theta will be equal to 1 over 9. So we can substitute sine square theta in this equation by 1 over 9. We did it, and we got that cosine theta equals to the square root of 1 minus 9. 1 minus 9 is 8 minus 9. 1 minus 1 over 9 is 8 minus 9. And the square root of 8 minus 9, the square root of 8 is 2 times square root of 2, and the square root of 9 is 3. So in conclusion, we found out that cosine theta equals to 2 times square root of 2 over 3, and sine theta equals to 1 over 3. So here, now we can put the values of sine theta that equals to 1 over 3 and cosine theta that equals to 2 times square root of 2 over 3 inside this trigonometric identity in order to find out the value of tangent theta over 2. We did it and we got that tangent theta over 2 equals to sinus theta, that is 1 over 3 over 1 plus cosine theta, and cosine theta is 2 times square root of 2 over 3. So we have here 1 over 3, and here we multiplied 1 by 3 and then we divided by 3 in order to have a common factor with this expression. So in conclusion, we got that tangent theta over 2 equals to 1 over 3 plus 2 times square root of 2 over 3. If we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. And in conclusion, we found out that tangent theta over 2 equals to 1 over 3 plus 2 times square root of 2. Then we actually, so we found out that tangent theta over 2 equals to 1 over 3 times 2 times square root of 2. Here we simplified this expression by multiplying it by 3 minus 2 times square root of 2, and then we divide it by 3 times minus 2 times square root of 2. So in the numerator we have 3 minus 2 times square root of 2, and in the denominator we have expression that is very similar to the algebraic identity that a plus b times a minus b equals to a squared minus b squared. A is 3, so a squared is 3 squared, 3 squared is 9. B is 2 times square root of 2, so b squared will be equal to 8. So it is minus b squared is minus 8. So in conclusion, we found out that tangent theta over 2 equals to 3 minus 2 times square root of 2, because 9 minus 8 is 1. And then we put the value of tangent theta over 2 inside the equation of tangent theta over 2 equals to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So we got that tangent theta over 2 equals to 1 minus tangent theta over 2, that is 3 minus 2 times square root of 2, over 1 plus tangent theta over 2, that is equal to 3 minus 2 times square root of 2. Here 1 minus 3, we open the brackets and we got that 1 minus 3 is minus 2, minus and minus is plus, so it is in the numerator we have minus 2 plus 2 times square root of 2, and in the denominator we have 1 plus 3 is 4, 4 minus 2 times square root of 2. So we found out that tangent theta plus alpha over 2 equals to 2 times square root of 2 minus 2 over 4 minus 2 times square root of 2. From the numerator we took 2 as a common factor, and inside the brackets we have square root of 2 minus 1, and from the denominator we took as a common factor 2 times square root of 2, and inside the brackets we have square root of 2 minus 1. Square root of 2 minus 1 over square root of 2 minus 1 is 1, so it will get cancelled. 2 over 2 is also 1, so it also will get cancelled, and we left only with 1 over square root of 2. So in conclusion, we found out that the tangent theta plus alpha over 2 equals to 1 over square root of 2. And according to equation number 3, we have already found out that tangent theta plus alpha over 2 equals to 5 over h, that equals to h over 5 plus x. And we just right now found out that tangent theta plus alpha over 2 is also equals to 1 over square root of 2. So from this long equation, we can derive that 5 over h equals to 1 over square root of 2. We first multiplied this equation, and we found out that h equals to 5 times square root of 2. Okay? And from this long equation, we can derive that 5h over 5 plus x equals to 1 over square root of 2. Here, h over 5 plus x equals to 1 over square root of 2. We have already found out that h equals to 5 times square root of 2, so we can substitute h in this equation by 5 times square root of 2. We did it, and we got that 5 times square root of 2 over 5 plus x equals to 1 over square root of 2. We cross multiply this equation, and we got that 5 times square root of 2 times square root of 2 equals to 5 plus x, and square root of 2 times square root of 2 is 2, and 2 times 5 is 10. So in conclusion, we found out that 10 equals to 5 plus x. We subtracted 5 from this equation, and we found out that x equals to 10 minus 5 is 5. So we found out that x that equals to CE equals to 5 units. Here, x that equals to CE, x that equals to CE is equal to 5 units. So the answer to the question is that x equals to 5 units. Okay, thank you very much.